Welcome to Math in the House. Today, we're doing Math Analysis, Chapter 1, Section 2, Properties of Triangles. I'm your host, Dr. D. So, first thing we're going to be doing is talking about triangles. So it's like a trip back in time to geometry. No, this will be really fun. Seriously. Okay. All right. Triangle classifications. First thing, we could classify triangles by their angles. So the first type of triangle would be a right triangle. Now, a right triangle means you have a triangle with exactly one 90-degree angle. And clearly, since all three angles have to add up to 180, the other two angles must be acute. And acute means less than 90 degrees. Okay. Second type of triangle would be an acute triangle. Now, this is one where all three angles are acute. And the third type of triangle would be an obtuse triangle, which is one obtuse angle, and then all the rest have to be acute. Now, obtuse means it's greater than 90 degrees. Okay. So, right triangles, acute triangles, obtuse triangles, those are all triangles classified by their angles. Now we're going to talk about triangles classified by their sides. So we've got a scalene triangle, which means no two sides are congruent. All three sides have different lengths. Then number 2 would be an isosceles triangle. And that means exactly two sides are congruent. That means two sides are congruent and the third side is not. And then we have an equilateral triangle, which means all three sides are congruent. Now, incidentally, this is a congruent sign, which you probably remember from geometry, it's an equal sign with a little squiggle above it. So these are congruent. All right, so let's take a look at what we have. First, right triangles. Now, right triangles say nothing about the length of sides, so we could have a right triangle that looks like this, or we can make it longer and skinnier, or we can make it shorter and fatter. But they're all right triangles. And, believe it or not, we could actually turn the triangles so that the right angle is somewhere other than the bottom. Aren't they? Okay, so now notice I have 5 triangles here, and one of them is not acute. Okay, so which one is not? Well, notice all 3 angles are acute here, so this is an acute triangle. All 3 angles are acute here, that's acute. All 3 angles look like 60 degrees here, so they're all acute. Here's one that looks almost 90 degrees, but not quite. So these are all 3 angles acute. This one! This is the culprit! So this is not an acute triangle because it has an obtuse angle in it. So all 4 of these are acute triangles. All right. Now, here are obtuse triangles. And once again, one of them is an imposter. Okay, that's enough of that. We're not doing that anymore. All right. Obtuse triangles. So notice we have, here's an acute angle, and an obtuse angle. So this is an obtuse triangle. Here's an obtuse angle, so that automatically qualifies. And here's an obtuse and other two acute. And here's an obtuse angle, just barely. And these are acute. Okay. But here, there is no obtuse angle. So this is not an obtuse triangle. Okay. So these four are obtuse triangles. You need at least, or you need exactly one obtuse angle to make an obtuse triangle. All right, now let's go with the triangles that are designated by the length of their sides. Scalene triangles. So a scalene triangle, all three sides have to be different lengths. So this one, clearly all three sides are different lengths. This one, you have the short side, the medium side, and the long side. So that's scalene. And here we have short, medium, and long. Now this one is the culprit. We have these two sides are congruent. So this is not a scalene triangle. So this one gets thrown out of the club. All right. Now, the next type of triangle are the isosceles triangles. Now, here's probably the shape that most people think of with isosceles triangles. And notice you have these two sides are congruent and this is not. Now, the side that's not congruent is shorter. Well, here's an example where these two sides are congruent and the side that's not congruent is longer. So notice we have a tall, skinny isosceles triangle, and we have a short, fat isosceles triangle. And now here's another example where it's almost an equilateral triangle, but these two are congruent and this one is not. Here's one where these two are congruent and this one is not. Yeah, this is the imposter, because notice this is the short side, this is the medium side, and this is the long side. So, no, it's the other way around. Rats. Okay, wait. Let's cut this. No, that actually is. Yeah, this is the long side down here. Okay. All right, let's just get rid of that thing too. And this one is the imposter, because you can see here's the short side right here. And then if I compare these two sides, this is the medium side and this is the long side. So that looks almost like an isosceles triangle. If this side was a little longer, it would be, but this is the imposter. The imposter. Okay. Now, equilateral triangles. All three sides are congruent. So we have small equilateral triangles, and we have bigger equilateral triangles, and we have the biggest equilateral triangle. And notice also that it doesn't have to be where the base is at the bottom and one vertex at the top. You can have it pointed any direction. Now, here is the imposter. This is not equilateral because this is the long side. And these two sides look like about congruent. So these are congruent, but that's the long side, so there's no way that's equilateral. Okay. So, now, can you draw a triangle that's both a right triangle and a scalene triangle? Okay, try it. Right triangle and scalene. Let's try it. So it's got to be a right angle. Let's put a right angle in here. Now, here's the thing. I'm making the bottom side longer than the left side because it's got to be scalene. And now when I draw the hypotenuse here, we have our right angle, and I have my short, medium, and long side. So there's a right triangle that's also a scalene triangle. All right, can you make a right isosceles triangle? Well, let's make the right angle at the bottom left again, just like we did before. But now the only difference here is we're trying to make two sides congruent because it's isosceles. So I make my right angle here, and then my hypotenuse like this. So these two sides are congruent, and this one is the long side, or the hypotenuse. So it's a right triangle, and it's an isosceles triangle. Okay, and now let's try to make a right triangle that's also equilateral.
Nice try, but I'm afraid you can't do that.
Oh, we can't do that. All right. Here's an extra credit assignment for you. I want you to prove to me that there is no such triangle. Now, you guys have had geometry, so you've had a taste of proofs. I'll give you a hint. This is an indirect proof. You're going to prove that there is no such thing as a right triangle that's also an equilateral triangle by an indirect proof, or you might call it by a proof by contradiction. So, see if you can do it. Okay. Now, can we have an acute triangle that's also a scalene triangle? Well, acute means all three angles are less than 90, and scalene means all three sides are different length. Can we make a triangle that's both acute and scalene? Well, what we'll do is it's almost like a equilateral triangle, only we move the vertex up the top over a little bit. So now this is going to be the short side here, and this is the medium side here, and this is the long side, and all three angles are acute. So that's perfectly possible to do. Now, how about acute and isosceles? Well, that's going to be like this. Acute and isosceles. So notice these two sides are congruent, and all three angles are less than 90. Now, what about acute and equilateral? Well, every equilateral triangle is acute, because with an equilateral triangle, all three angles are 60 degrees. So, like I said, all equilateral triangles are automatically acute triangles. Okay, now, what about obtuse and scalene? Okay, well, that means we just have there's our obtuse angle right here. And then we have our short side, our medium side, and our long side. So obtuse and scalene. Okay, now what about obtuse and isosceles? Okay, so here are the congruent sides, and here's our obtuse angle. Now, last are obtuse and equilateral. Well, remember, we said before that every equilateral triangle is acute. So this cannot be done. Okay, so that's it. Let's cruise onward. Now, when we label the parts of a triangle, we always label the vertices with capital letters, and we label the sides with lowercase letters. So notice we have angle A, angle B, and angle C, capital letters, and then side A, which is opposite angle A, side B, which is opposite angle B, and side C, which is opposite angle C. And, like we learned in geometry, angle A plus angle B plus angle C have to add up to 180 degrees. Now, technically, we should be writing the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. But what we're going to do is we're going to call the measure of angle A just A, and then the measure of angle B will be just B, and the measure of angle C would just be C. So that's it. Okay, so as you remember from geometry that the sum of the angles of the triangle equal 180. So we're just going to take A as the measure of angle A, and B is the measure of angle B, and C is the measure of angle C. Now, the next thing we know about the sides of the triangle is that the sum of any two sides have to be greater than the third side. So that means A plus B has to be greater than C, A plus C has to be greater than B, and B plus C has to be greater than A. And now, likewise, if I subtracted B from both sides, then C minus B has to be less than A, and B minus C has to be less than A, and A minus C has to be less than B. So those all work also. Now, the next relationship between sides and angles, if a side is less than another side, then the angle corresponding to that side is less than the angle corresponding to the other side. So if A, notice, angle A is less than angle B, well, that means the side opposite angle A, side A, has to be less than side B. And likewise, B, angle B, is greater than angle C. So that means side B is going to be greater than side C. So it's basically like a door with a hinge on it. So A is the hinge, and C is the door. And if the door is open a wider angle, then the doorway will be longer. The space in the doorway will be longer. So that's the deal. If the angle opens wider, then the side opposite is longer. All right, now, so we're given that triangle ABC is similar to triangle DEF. Now, this is the symbol that means similar to. It's like the squiggle without the equal sign under it. So ABC, triangle ABC is similar to triangle DEF. Now, notice the way we list the triangle, A and D are corresponding angles. B and E are corresponding angles, and C and F are corresponding angles. So, angle A equals angle D, angle B equals angle E, and angle C equals angle F. That means that triangle ABC is similar to triangle DEF. Now you can see that triangle DEF is bigger than ABC. That's what similar means. Even though the angles are the same, the sides are not the same. They are proportional. And proportional means that side A divided by side B equals side D over side E. So notice A over B, so right divided by bottom of the small equals right divided by bottom of the big. And A over C equals D over F. So right over left equals right over left. And B over C equals E over F. So bottom over top equals bottom over top. So that's what it means to be similar triangles. All three angles congruent, all three sides are proportional. Now, this seems like one of those goofy math problems in a math book that never actually is encountered in reality. But I have a friend who was head groundskeeper at Pomona Valley Hospital, and he was given the assignment to report all the heights of the trees on the grounds. I have no idea why, but they actually asked him to do that. So he called me and said, "How do I do that?" Well, there are a couple of ways to do it, but similar triangles are a convenient way of doing it. Let's say a person who has a measurable height is standing on the ground, on flat level ground, and the sun is shining, and the angle of the sun produces a shadow. So the person's 6 foot tall and the shadow is 10 feet. Now, you have a tree of unknown height. This is a beautiful palm tree, courtesy of Uni Kim. Okay, so we have a tree of unknown height, and I don't want to have to climb that tree with a tape measure to try to find out how high it is. So what I do is I just say the height is X. Now, the shadow I can measure. Now, are these two similar triangles? How could you guarantee that they are similar triangles? Well, first of all, we know that the sun is the same angle in the sky, no matter if you're talking about a person or a tree. So it's close enough to the same that it really can be considered equal. So that means the top angle here is congruent to the top angle here. Now, the second thing is, it's flat ground, so the second angle here is a right angle here. So this triangle has a right angle on the lower left-hand corner. Same thing here. The tree grows straight up, right angle here. So we know we have two angles that are congruent. That means the third angles have to be congruent because it's all three angles have to add up to 180. Okay, so we know that we have two similar triangles here. So that means the sides have to be proportional. Now, we don't care about the hypotenuse up here, the third side that goes from the top of a person's head down to the ground. All we care about is the length of the shadow and the height of the person or the tree. So basically, our proportion then is 6 over 10 equals x over 25. So this is our proportion. Now, all we have to do is solve for x. So you know all we do is cross multiply, and so we know that 10x equals 6 times 25, which is 150, and that means x equals 15. So that says the tree is 15 feet tall. That's it. Game over. Have fun with these.